Right, I've just received this 12 volt wireless remote control unit. It's two parts, the transmitter and the receiver. It's two channel. The receiver has two relays, but the transmitter has actually four buttons, and there's good reason for that, which I'll show you in a moment. Now, this module came from icstation.com. It's their product code 2709, and the current price is $9.68. And if we have a quick look at the data here, it says working voltage 12 volt DC, current less than or equal to 9 milliamps. This is a 315 megahertz frequency RF system. Transmission distance 200 meters in open space. Now that will be reduced if you've got buildings and so on. Fixed code encoding, I'll show you what they mean by that, and so on. Now, these wireless modules are based on a remote control encoder and decoder set. This is the decoder, the SC2272, and this is an L4 version. And the encoder on this unit is the PT2262. Now, both the receiver and the transmitter run on 12 volts. The transmitter uses one of the little 23A 12 volt remote fob batteries, and the transmitter requires 12 volts. Now, on the board there's a 5 volt regulator, which I'll just point to, which is down there. So the decoder chip and the wireless module are taking 5 volts, but it requires 12 volts on the input because these relays have a 12 volt DC coil. So I was interested in what the range of voltage that 12 volt DC coil will take, and I found a datasheet on this HK3FF relay, and if we scroll down to the bottom to coil data, on the 12 volt line, it looks like, it says maximum operate voltage, but I think it means minimum. 9 volt minimum pull-in voltage, and 15.6 being the maximum voltage. So that's fine for lead acid batteries, which will typically range from 11 to 14.5. So let's see this thing working. I've got 12 volts into the receiver unit, and it appears that the two channels that have been implemented are on buttons B and C. So if I press button B, that relay comes on, C, the other one comes on, and they latch. So the only way to switch them off is to press a channel that's not in use, like A or D. Those two channels aren't in use, so that switches relays B and C off. Now you can, if you're quick, press both B and C together and get both channels to come on. And you could use that as a security feature, because if you had one thing that you wanted to switch, you could wire it through both the first relay and then in series the second relay, and it would require that you press both buttons to get it to come on if you wanted that little extra bit of security. Now, this unit is supplied with the L4 variant of the chip, and that means that it's got 4 implemented channels and they're latching, but you can also get an M4 variant of this chip, and I'll just put that in now to show you what the difference is. So the M4 chip is now in there, and you can see that if I press on the remote B, it only stays on now while I'm holding that button, and similarly C. So this is non-latching, this is momentary action. And it's worth pointing out that icstation.com, because they also sell ICs, have in their range of products the L4 chip, the M4 chip, also surface mount versions if you want to do that sort of thing, and they also have the M6 chip as well. Now, on the back of the receiver unit, you've got 8 of the pins of the decoder chip are between these 2 rows of exposed pads, and the idea is that by pulling these 8 pins either low or high, or leaving them open circuit, you can put on your own security code. And if you look on the transmitter chip, you've got the same row of 8 pins which can go low or high. The H and the L are actually marked on there. Or, as I say, there's a third state, which is to leave them open circuit. Now, as supplied, this unit has, and in fact I need to look at the transmitter for this, it has address pin 8 pulled low. You can see the little blob of solder there. All the other pins are open circuit. Now, normally these things are supplied with all of the pins open circuit, but actually it's quite a good thing that they've coded it with at least one of the pins has been pulled to something other than open circuit, because what you don't want to do is have someone else using one on the same default channel of all pins being open circuit and therefore interfering with what you're trying to do. So with 8 address lines and 3 states per line, the number of address combinations are 3 y to the x 8 equals, and that is 6,561. It's 3 to the power of 8. So I've just had the soldering iron on this thing, and I've put a code on there, at random really, just some of them high, some of them low, some of them open circuit. But as long as the transmitter and the receiver codes match, then the unit still communicates. So just make sure that's still working with the new code. And there we are, that's fine. Now the data sheets for these chips can be quite confusing because they try to show all the different variants of the chip in one data sheet. So here's what looks like the original Princeton Technology data sheet for the PT2272, and then I've also got the Sylvan chip SC2272, which I assume came later because it says compatible with the PT2272. And on the PT2272 datasheet it shows a whole bunch of variants, including the 2272, the 2272A, M2 or L2, and then there's also an M3 or L3, M4, L4, M5, L5, M6, L6, and on the next page you've got a whole load of 20-pin versions, which are probably the surface mount ones. Now if you look at the pinout for the PT2272 M4 or L4, you can see that on the left you've got 8 address lines, A0 to A7, and on the right you've got 4 data lines, D0 to D3, and the address lines are the pads that are on the back of the board, and the data lines on this module, as I say, only 2 of them are implemented and pass through to the relays. Now if you don't fancy either the latching action or the momentary action, there is actually a third variant, which is the T4, and that's a toggle action. I don't have one at the moment, but I did buy a couple just to see what they're like. And of course that one, if you press the button once, the relay comes on, and then you press it again, the relay drops out. But they're not as common as the L4 and M4, and I believe they were actually manufactured by a different company, because the datasheet for the Sylvan and Princeton ones don't mention the T4. So why not just use the M6 L6 in every version of this product? Well, you can see that on the left there, with the extra data lines, you're removing some of the address lines. So the M6 and the L6 chip only have 6 address lines, and therefore they have far fewer combinations for data security. 3 to the power of 6 is only 729, whereas with 8 address lines it was 6,000 and something. Now the receiver unit comes with these plastic standoffs which are for panel mounting, but I'm not going to use those. I'm screwing this down onto a piece of wood. This is sort of my new LED project board, and this is where you appreciate the proper M3 holes on this module. Also, they're properly spaced out from the connectors, so you can actually get screws in. If you compare that with this wireless unit here, you can see it's got silly 2mm holes that are actually part obscured by the connectors. No good at all. So here we have a quick lash up, 12 volts going to the supply pins of the wireless receiver module, and then the positive going through one of the switching channels and to an LED driver board and to a 20-watt LED. And so here's a quick test, a short range test with the LED board hooked up to a 12-volt power pack, and press the B button and on comes the LED. A button to turn it off. And here's a slightly longer range test. Lighting conditions aren't ideal at the moment, but the LED is right at the bottom of the garden, so let's press the B button. There it is, comes on. A to turn it off. Try that again. And that works fine. So there it is, that's the 12 volt 2-channel wireless remote control, and that came from icstation.com.